Welcome to the Real Python Podcast. This is episode 271. How does Python 3.14 perform under a few handcrafted benchmarks? Does the performance of Async I/O scale on the free-threaded build? Christopher Trudeau is back on the show this week, bringing another batch of PyCoder's Weekly articles and projects. At the top of the show, we have a mountain of release news and Python enhancement proposals to cover. Then we dig into a couple of articles covering the performance of Python 3.14. The first is a benchmarking comparison between the last several versions of Python and their variations, including the JIT and free-threaded mode. The second explores the changes made in 3.14 to enable Async I/O to scale on the free-threaded build of CPython. We also share several other articles and projects from the Python community, including an introduction to NiceGUI, a free-threaded Python library compatibility checker, what is good taste in software engineering, HTML templating with T-strings, and a tool for testing Sphinx docs instantly in the browser. All right, let's get started. The Real Python Podcast is a weekly conversation about using Python in the real world. My name is Christopher Bailey, your host. Each week, we feature interviews with experts in the community and discussions about the topics, articles, and courses found at realpython.com. After the podcast, join us and learn real-world Python skills with a community of experts at realpython.com. Hey, Christopher, welcome back.
Hey there.
All right. Well, it's the couple weeks after Python 3.14 is released, and, well, the news did not stop. There's a whole bunch of stuff going on and a whole bunch of releases to start with, and then a whole bunch of PEPs. And we'll have our usuals. We actually have a short discussion this week, which I think will be kind of fun, and some projects. So, ready to dig in?
Yeah, welcome to the all news episode of the Real Python Podcast. At least it's gonna feel that way.
I'll be back here.
Well, yeah, that's exactly. Get comfy. All right, so let's get going. So, in conjunction with the 3.14 release, as you just mentioned, lots of fixes have gone out for the other Pythons as well. So 2 days after 3.14, hot on its heels came 3.9.24, 3.10.19, 3.11.14, and 3.12.12. These are all security releases with a couple of fixes related to XML files, a couple with archiving, and a bunch of HTML parsing issues. Notice the lack of 3.8 in that list. It has gone end of life, so time to update my Knox files. One less thing to test.
Yep.
Actually, and one more because of 3.14. Yeah, that's how it usually works. You might also notice that 3.13 wasn't in that list. That's because 3.13 had a security release the day after 3.14, but I didn't mention it because a week later, 3.13.9 came out, fixing a regressive defect introduced by that same security fix. So we're going in circles.
Yeah, steps forward, steps backwards.
And in case you're not tired of me babbling numbers in your ear just yet, 8 days after 3.14 came 3.15 Alpha 1. Yeah, you don't even get a chance to breathe.
Nope.
The contents of 3.15 haven't been finalized, but so far they've committed to a sampling profiler, which I'm looking forward to. The new interface for creating bytes, objects, and C APIs, which we mentioned the PEPs a couple weeks ago, changing to use UTF-8 by default when encoding, and in the continued tradition since 3.9, even more error message improvements.
Yeah.
From one stream of numbers to a completely different stream of numbers, this week is Pepalicious.
Yeah, it is.
Let's start with PEP 804, titled An External Dependency Registry and Name Mapping Mechanism. This is a packaging PEP. Packages on PyPI often have build and runtime dependencies that aren't available on PyPI itself, and a previous PEP described how to capture this information as part of the package's metadata. This PEP describes the creation of a registry that can store and map this info. So, for example, if your package is dependent on the Clang compiler, this will store that for other build systems, think like Linux and packaging, things like that, so that they can find the associated dependencies. At the moment, all of that is really done manually, and they're essentially trying to put it somewhere so that it can be automated a bit more. Next up is PEP 806, titled Mixed Sync and Async Context Managers with Precise Async Marking. As a reminder, a context manager is a class that can be used in a with block. There are both with and async with variants for synchronous and asynchronous code within the block. Currently, you can open multiple context managers in a single with, but as you can't mix and match with and async with, you can end up with a lot of nested blocks when you've got both synchronous and asynchronous resources. This PEP proposes allowing the use of the async keyword next to the context manager itself. This is one of those places where audio isn't the best format for conversation. It's like a 2-line code example, but imagine you are opening a file and a lock. Currently, you can say with open as file, comma, acquire lock as lock. But if the acquire lock method were async, you can't do that in a single line. The proposed change would allow with open as file, comma, async, acquire lock as lock. So moving the async into the actual with statement, and this will let you mix and match the two variations of context managers in a single statement, reducing the amount of nesting needed for complex resource management.
Yeah, looks much cleaner in a way.
Yeah, it's a simple syntax change, and for certain cases, it can drastically reduce the amount of code you've got to do. So it's easier to look at.
Yeah.
It's might even be better taste. Well,
oh, hint dropped.
That's some foreshadowing. Moving on, PEP 807 is index support for trusted publishing. So currently PyPI has a feature called trusted publishing, which uses the OpenID Connect standard for credential sharing. This feature allows you to publish with credentials through an API, allowing things like a GitHub publishing hook. Trusted publishing is sort of an ad hoc feature and doesn't currently have a way to do discovery, so you can't programmatically ask PyPI if it supports this feature. The PEP aims to standardize how this is done so that other packaging systems can implement the feature and tools can determine whether any given packaging system exposes the trusted publishing API. Several of these are pretty dense. I suspect there's been a bit of a gold rush here to get things into 3.15 before the feature freeze happens. PEP 809 is stable ABI for the future. We've been talking about this. There have been a couple other associated PEPs with it. The ABI is the interface that Python uses to talk to compiled extensions. This interface ensures that you don't have to recompile something. So say you're using NumPy, you can use it for every single version of Python because it's against that ABI. Adding free threaded mode to Python has required changes to the ABI. And so to go along with that, this PEP talks about what future ABIs would look like and also how to have an ABI discovery process to help the extension writers determine compatibility and dependencies. So
free thread is going to come up a bunch today.
It is. You still awake over there, Mr. Billy?
Yeah, I'm doing good.
I think I have to have a word with our union about the imbalance of workload here. All right, one last PEP, 810, which is explicit lazy imports. This has been getting a fair amount of buzz on the internet. Right now, all imports fire when your code starts up. For large programs, this can be expensive. Say all you want to do is do the, your program -- version. Well, you have to import everything in order to get at the argparse call that does that. So there are ways around this, but I'm going to skip over that for the moment. The idea behind this PEP is to introduce a new keyword for use in the import statement. So you'd do something like lazy import JSON instead of just import JSON. A lazy import wouldn't get loaded until you actually start to use the module. So if, again, back to that JSON example, if say you were using it inside a function, the actual loading wouldn't fire until you called that function. The import system might seem simple from the outside, but there's a fair amount of complexity underneath. The devil will definitely be in the details on this one.
It's definitely one of these things that we've talked about before with this idea of like Pythonic code and the idea of like you need to have your import statements at the beginning of your code. And that was a practice I would see often in like things like notebooks and stuff like that. It'll go back to our conversation later where people would be like, oh, I guess I need this library. And then they would just add the import statement there. And it's funny that this is sort of acting in that way that they think it is like, oh, I do need that now.
Yeah, where it gets complicated is oftentimes you've got module level variables that are used as singletons. And so once you start lazy loading, that isn't going to get instantiated until after that module loads, and there might be timing issues. So it could get a little weird.
The trick is to make things start running generally faster, not needing quite the overhead to start with. That's one of the pieces.
Yeah, that's the hope. Yeah, and if you think of something like a program that's got pluggable pieces, you shouldn't have to load those things until you actually needed them. I see it all the time. Like when I start the GIMP image program, it sits there and goes loading plugins, and that takes a lot longer. And I never use any of them, right? So if you could push that off till later, I wouldn't have to sit there and watch it do that.
Yeah, totally.
So I mentioned that there are some ways around this already. You don't actually need a language feature for it. So Brian Ocken just wrote a great article showing you a whole bunch of different approaches. He writes about different techniques for doing lazy importing in existing versions of Python. Also, there are third-party libraries that can help you do this as well. One of them is the wrapt library, that's spelled W-R-A-P-T. This library is a utility for writing decorators, but it can be used to wrap importing as well, giving you lazy loading. So we'll link to Brian's article as well, a recent post on the wrapt library from one of the maintainers of that system.
All right.
I think it's finally your turn. I think I'm going to go make a tea and soothe my throat here.
Yeah, totally. All right. A month ago, I know it seems crazy, but that's our last PyCoders episode before 3.14 came along. I featured a piece by Miguel Grinberg, and it was about measuring the performance of MicroPython on various microcontrollers and comparing that performance to full computers. Raspberry Pi were some of the examples, and the Linux computer, and then a Mac. Well, with the release of 3.14, he has written a blog post. It's titled, Python 3.14 is here. Period. How fast is it? This is sort of a follow-up. He likes to do this. Another blog post is titled, Is Python Really That Slow? From November of last year. Like in the post about microcontrollers, he stresses that benchmarks can be misleading, along with a theme that he runs through a lot of these things. Running benchmarks is fun, but not necessarily accurate. His benchmarks are designed to run as pure Python code. There's not dependencies, particularly not using functions, again, going back to your ABI thing, things that would need that are written in C. So this is native code. And so it's not as likely to change as far as speed from one Python release to another versus a lot of these underlying potential dependencies. So again, your mileage is going to probably vary because your programs probably use a variety of dependencies and a mixture of maybe native plus Rust or C or C++ or whatever you have inside there. So he describes a testing matrix that he's designed here, 6 Python versions, plus recent versions of PyPy, that's PyPy. The alternate interpreter that we've mentioned a few times on the show, he also compares it to Node. So he's kind of done a restructuring of the code to run, on the JavaScript Node system, and then Rust also, which is interesting, just to kind of get an idea of like, how does this stuff run? He uses 3 Python interpreters in a second set of tests. This is it running standard. This is with the JIT, only for CPython 3.13 and 3.14, obviously. And then free threading mode, which again, both are only available in CPython 3.13 and 3.14. He wrote 2 test scripts. One calculates Fibonacci numbers, just called fibo.py. It relies heavily on recursion. And then a bubble sorting one that he uses called bubble.py. And it sorts a list of randomly generated numbers using bubble sort algorithm with lots of iteration and no recursion. The other test that he does that's kind of interesting is he decides, now that we can do threading and test against a free threaded version of Python that's not using the GIL, what's that look like? So he has a single threaded pass of all these tests, and then one using a set of tests doing 4 threads running independent calculations. 2 computers. He has a framework computer that uses Ubuntu Linux and a Mac laptop running macOS Sequoia, an M2, I guess. So the Fibo.py, he's got it calculating the 40th Fibonacci number, and it took a few seconds, and that was a good test for him because it was at least not in like microseconds or milliseconds. Here, it's running for a little while. And By the way, this is the one that failed on the very low RAM units in the microcontroller test last time. So the other bubble.py, he has it set up to do 10,000 randomly generated numbers. So he stresses they're not fantastic examples, but that's kind of part of the point. They run fairly quickly, though there isn't any optimization in the code. It's very easy to read. If you're a beginner, you would actually be able to see what's happening. Good examples there of ways that you could kind of create your own little simple. We always get abused of saying the word simple, but pretty straightforward examples. So one's recursive, the other is not. He has the code run 3 times and then has a timer on it. So what's the chart show? So 314 has gotten a nice speed improvement over 313. It ran close to 27% faster. Again, this is his own little personal benchmark, which is interesting. 311 is the point at which Python versions really changed in a lot of ways. There's a lot of rewriting of the code, and his chart here showing it moving from being very slow to not so slow. And 314 does improve upon it. What's interesting is that there's some versions there that don't run as fast. There, in fact, 312 and 313 are actually a little slower than 311. And so 314 is a return to this speed up that 311 was providing. PyPy is still really impressive, slightly faster than Node.js and almost 5 times faster than 314. He does that free threading test also, which running in standard free threaded mode, and then also including the just-in-time features, the just-in-time compiler. The free threading interpreter, if you aren't familiar, you're catching up to some of our episodes here. It disables the global interpreter lock. It's an interesting test to run it with only one thread, but what you'll see is that it wasn't much of an improvement if you're just running a single thread, which is kind of against the point of it. But also we talked about they're still optimizing the code in here. And so for the Fibonacci one, the free threaded mode was slower, but much better than what was happening in 313. He goes on to the bubble sort benchmark, which showed similar improvements, though the PyPy was 18 times faster than 314 and even faster again than Node. So pretty impressive results here. He then goes into a whole set of tests, again, with 4 threads. These tests did not include PyPy or Node or Rust comparisons in this case. Hard to explain charts here, but you can kind of get an idea that, yeah, 314 has some improvements. 314 really starts to shine with the JIT and free threaded mode. His quote is, "The free threading interpreter is showing us how removing the GIL can help with running multiple threads that are CPU hungry." And again, nice comparisons. And again, like many benchmarks, results are going to vary. So thanks, Miguel, for running these tests. And if you're interested in seeing all this, and I think it'll help, he includes tables with his actual numbers. I mentioned a link during our 314 release discussion 2 weeks ago that showed compatibility of libraries with free-threaded Python. I have a different one this week that is by Dongyi Na, and it's at ft-checker.com. And this one is hosted by the PSF. It's a little different. It has a heat map showing the libraries that are now able to run in free-threaded Python. You can see the compatibility of all these different Python packages. And it shows, in this particular case, not only 314 free-threaded, but also 313, because there might be some subtle differences there. You can browse through the tables that are included, and then there's also a search box if you just want to get right to a particular library and see if it can run in free-threaded mode for you.
It's nice to see that the performance of the free-threaded mode with a single thread is improving.
Yeah.
The steering committee has made it very clear that it won't become the default unless we get to a place where there isn't too much of a performance hit. So, it's not quite there yet, but
yeah,
it's starting to feel like it's something that is attainable.
Yeah. It's interesting to see these types of things, and I guess you'll have to see what the performance looks like difference-wise, but there was a lot of work across these 4 versions from 311 all the way to here to 314, and I don't know what they're adding in 315 as much. I'll have to dig into that as far as potential other speed improvements, but it has been a focus, and you can see the results here.
Yeah, I suspect with some of the 3.14 performance improvements, like they've had the hood open because they've had to have the hood open because of working on, we've had to make it a whole bunch of stuff thread safe that didn't have to be thread safe before. So, if you're in there, you start going, oh, wait a second. Oh, well, I'm going to add the lock. That's going to make it slower. Well, what else can I do to speed it up? So I think we're starting to see.
We talked about the garbage collector and all those kinds of things.
I think we're seeing side effects of the free threading process even outside of the free threaded space.
Yeah, cool. Speaking of speeding things up here, you ready to dig into your first topic here?
Yeah, sure. So there's been with the 3.14 release, there's been lots of content out there, but there's always little corner stuff that maybe gets a little more overlooked. My first article this week is by Jimmy Chang, and it's called Python 3.14 3 Async IO Changes, and it covers some of that overlooked stuff. So Async IO implements coroutines, which are a way of doing concurrency in Python. These are kind of like threads, but instead of being under the operating system's control, they are controlled by Python. So to create what you would call is a coroutine, you declare it with the async keyword. And when you're calling it, you use the await keyword to wait on its response. That waiting is more than just waiting, though. It's also signaling that you're willing to give up control of the coroutine, allowing others to be scheduled. So this is where you get that concurrency happening. Debugging this can be problematic. Let's say you're using the built-in PDB debugger. In a synchronous program, you would call PDB set trace or the built-in breakpoint function, and your code would stop at the spot where it hits that line. And this allows you to inspect the system there, and then you continue on as you're ready. Of course, if you try to do this in an async function, you're going to have a problem. You can't await it because it's not asynchronous. Python 3.14 solves this by adding another function to PDB, set trace async, which you can await. Jamie also mentions a feature I didn't even know existed. Evidently, since Python 3.8, so it's been around a while, you can start an async-ready REPL by calling python-m asyncio. So if you're debugging async resources, that's the REPL you want to launch instead. You may have heard us talk about the fact that Python now supports connecting to a live process for debugging and other things. Well, the second feature in the blog post is one of those other things. There are two new commands in the Async.io module, ps and pstree, both of which print out information about running systems. They print the same info in two different formats. One is a table and the other is like a nested tree kind of look. You use them by invoking python-m async.io ps and then the operating system ID of the process that you want to introspect. This is kind of cool. It lets you see what's going on inside of your coroutines. Note that on some operating systems, this might be a privileged command, so you may also need sudo to get this to work. The third feature has come about as part of the free-threaded get rid of the GIL work. Previously, the async.io code wasn't thread safe, so you couldn't run coroutines in threads. As part of the prep for free-threaded mode, this has been changed, and while working on the code, they also managed to make it faster, which kind of back to what we were talking about before.
Yeah.
Jamie references Kumar Aditya's blog about doing these changes in Python 3.14, which we'll link to in the show notes as well, in case you want to go to that one directly. Jamie's post has some good examples for each of these three changes, so there's plenty to dig into there if you're interested in Async.io. While I'm on the topic of Async.io, there's one thing that I think is worth mentioning. The interface to Async.io has changed a bit since its original creation, and a collection of classes and methods got deprecated in Python 3.12. Well, along with that, the default behavior of the getEventLoop function has also changed. So if you're new to Async.io, that's not a big deal because all the tutorials show you how to use the run method instead of getEventLoop. But if you're running older code, well, that can be problematic.
Or a really old tutorial, right?
Yes. So that deprecation became a removal in Python 3.14. So if your code was using getEventLoop, it probably won't work with the latest version of Python. I bumped into this twice in the last 2 weeks with third-party libraries that use the old way. Thankfully, the change is a one-liner, and the libraries actually caught up a couple days after I bumped into it. So, sometimes upgrading can be a little problematic.
Yeah. So there's a ton of 3.14 resources for you. I wanted to stress that we worked really hard at Real Python here. Bartosz Jasinski kind of led the charge along with the rest of the team. He had his article, The 314 Cool Features for You to Try. I'll include a link for that. You, Mr. Trudeau, worked on the What's New in Python course for 314. We had our podcast 2 weeks ago, and then there were a couple articles that dove much deeper into the details of like the REPL autocompletion and highlighting. There was a 314 preview for that, a 314 preview for lazy annotations. That lazy word keeps getting used a lot here lately. 314 preview for better syntax error messages. Again, the continued march forward on making the syntax error messages better. And then template strings, which we've covered a bunch on the show, but also there's another preview in there. And then, of course, your course was on that recently. And then wrapping things up, the free threading and JIT compiler. We had a preview of that went into much more detail, actually from 313, can give you some ideas of what's happening under the hood there. So lots of resources for you at Real Python for that. It's time to shine a spotlight on another Real Python video course. And in this case, it's one that I mentioned in the project section this week. It's titled Documenting Python Projects with Sphinx and Read the Docs. The course was written and presented by Christopher Trudeau, my co-host. As the course instructor, he takes you through how to write your documents with Sphinx, how to structure and style your document using RST syntax, incorporating your code comments and doc strings into your documentations using the PyDoc plugin, and then how to host your documentation on Read the Docs. Updates to the project's GitHub page can also update your docs, and the course includes a cheat sheet for using RST syntax for Sphinx. Real Python video courses are broken into easily consumable sections, and where needed include code examples for the techniques shown. All lessons have a transcript, including closed captions. Check out the video course. You can find a link in the show notes, or you can find it using the search tool on realpython.com. My next one, I wanted to share this tutorial. It's by Mo Hazian from his blog, HaziMed Tech. It's titled Meet NiceGUI, the nice guy of Python web frameworks. Now, I covered this library in episode 263. I featured it as a library during my project section there, and I pronounced it NiceGUI, kind of emphasizing the GUI of the graphical user interface of it. But supposedly, they would like it pronounced as guy. I might end up putting a little bit of an accent on it. So it lets you build modern web apps with just Python, no HTML, CSS, or JavaScript required. In fact, much of that's happening kind of under the hood. There's an underlying layer of this thing called Quasar, which is a Vue.js engine. And so you can scale feature-rich micro web apps and dashboards and multi-page apps and navigation themes and charts and stuff. I really like the library a lot. And so what Mo is providing here is kind of a quick tour and sort of a hello world of working inside of NiceGUI. And so he has you build a Celsius to Fahrenheit converter. I think his first example may have changed in his mind because it's still labeled as simple task tracker, but you're really building a Celsius to Fahrenheit converter. Maybe his ideas kind of changed as he worked. The first step is you import NiceGUI. It's spelled NiceGUI. Build the conversion functions. You're building a couple functions for going from Celsius to Fahrenheit, adding labels and inputs. What's nice is that it's under the hood doing all this work for you. In this case, the library that's under the hood is Tailwind CSS. So it's using those classes and styling and so forth, which look very modern and nice. You then update the functions, you add buttons, and then you just run the app. The second app that he shows off is diving a little bit more into the interactivity or reactivity, as it's referred to often. It's a real-time text character counter. He shares some more types of projects that could be done, but this real-time text counter, as you're typing words inside this text field, it's showing you a real-time status bar, and it's updating with every single letter you're adding or potentially removing inside there, which is kind of neat. And you can see that reactivity to it. He shares some more types of projects that could be done, including things with notifications, charts. We love dashboards here. At least I do. Multi-page apps, customized themes and layouts. And he wraps up with advantages of using a library like this. You get to avoid much of the web development world, which is a very deep path you can get into, and the ability to make visually appealing stuff that looks modern and are interactive without having to be this front-end web professional. And so NiceGUI has a website at NiceGUI.io, and it has a very large collection of examples that take you directly to GitHub, where you can try them out. And in fact, it looks like a lot more than just what I talked about 2 months ago. So they've been busy adding additional examples and tutorials for you to check out. It's definitely a great resource, and the documentation is also really good and thorough. So thanks, Mo, and thanks again to the team behind NiceGUI. So we are moving into a little discussion. We kind of hinted at it a couple times here. I think this will be kind of fun. So what do you got for us, Chris?
Yeah, so because we haven't done a discussion in a while, I thought we'd stick with our theme in our news segment and go over all 701 PEPs in order and rank them individually.
I'm ready. I got more coffee.
You hear that? That was the sound of thousands of people simultaneously reaching for the stop button on their podcast player.
Wait, come back.
Of course, I'm joking. Our discussion is inspired by an article by Sean Godecki called What is Good Taste in Software Engineering? In the article, Sean distinguishes between the idea of technical skill and technical taste. So let me quote him just for a second. You can be technically strong but have bad taste, or technically weak with good taste. Technical taste sometimes runs ahead of your ability. You can tell good food from bad without being able to cook. So Sean outlines a few things that he thinks governs taste. What code looks good versus what code looks ugly to you? Which design decisions do you feel good about, which are just so, fine or meh? What software problems bug you outside of work that you can't quite let go of? So one example Sean uses is the use of map and filter. He's a big fan, but recognizes that might be a matter of taste. Someone like me who prefers for loops may be more or less skilled, but we value different things, and so we like the two different approaches differently. A lot of this comes down to trade-offs. Having a high degree of resiliency in your code might be traded off against readability. Code that's heavily optimized for speed probably isn't going to be as portable. We see this all the time in the Python world. By choosing Python, you're likely favoring development speed over maybe code performance, although even that's a blurry line because of, NumPy and those kinds of things.
Yeah, potentially readability also, right?
Exactly. So before I start splitting hairs, what did you think here?
You are a person who's worked much more often inside of a business, and how you have occasionally mentioned this idea within a team having a specific code style that kind of is like a shop style.
Yep.
And I feel like someone new coming in and that struggles against that right away would raise the flag of bad taste.
Yeah, and it's kind of one of his primary premises in the article is being there is a right way to do this, and coming into a team and not accepting what's there is kind of one of these signs of bad taste.
Yeah, this inflexibility is another key in there. I have met people in more, let's just say different, scenarios, not programming per se, where they've come in and maybe they're fresh out of the oven of school and, or college or what have you, and they have such strong opinions that have been hammered into them, and they start to do things in a way, and you're just like, I liked some of the Hacker News, because this is kind of got tied into that. He actually released it on Hacker News and actually then responded to some of it later in the article. And I really like the Hacker News response of, I don't tell a junior engineer that what they are doing is less than optimal. I ask them why they are doing it that way.
Mm-hmm.
And I can imagine the, being said after the explanation.
Right.
And having to have that person explain why they're doing the thing that they're doing might throw light bulbs on inside the situation, or it might not. It depends, and makes it into a conversation as opposed to an attack.
Yeah,
which I think is an interesting approach inside there. Have you dealt with that yourself?
Yeah, a little bit. We've talked before about the fact that you can write any language in any language, and the whole
right.
the word Pythonic, right? So one of the startups I was at, we decided to use Python, we hired a bunch of developers that were good developers that didn't have a lot of Python experience. And it took a while to get that to shift, right? And I can remember looking at some of their code and going, that's it's like someone speaking with a foreign accent, right? Like you can see the Java in this in the approach,
exactly.
right? It's like you don't need objects for any of those things that you have made objects, and so like I think that's part of it. And this is where, and one of my experiences with the article was like I'm reading it and I'd hit a sentence and I'd be like, no, wait a second. And then I'd read the next sentence and go, oh no, now I understand what he's trying to say.
Yeah.
And I don't know why I kept going back and forth, what caused that. Some of it might have just sort of getting lost in the analogy, right? So like we often, when we talk about somebody having bad taste, we never say that kindly.
No.
Right. And so, if I don't like the way you dress and I say you've got bad taste, it's like there's something inherently wrong with you.
Right.
And so this is where I think and that's not what he's trying to say in the article at all.
Yeah. It's too hard of a slam, in some ways. Yeah.
And I think that's kind of where the analogy breaks down. And I think that's where I sort of rubbed up against it a little bit. But really, he's got in the article, he's got a list of these values, and there are things like development speed and optimization and stuff that we were talking about earlier. And what he's saying is that for a given context, best practice, what values you emphasize is going to be different than some other context. And of course, where you as an engineer are more comfortable might be a different set of those than the others. And so you might have good taste in one context, and then the bad taste is when you try to blindly apply that to another context, right?
Yeah.
And unfortunately, it's also it's one of those things where it's kind of hard to define exactly. He kind of ends the article with this: how do you get better at this? How do you develop better taste? And that was kind of what gelled with me most, was like he said, oh, well, work on a variety of things. And I've seen this all the time, right? So I've often found that when I pick up a new coding language, it's helped me understand previous languages better. It's like, oh, now I get why they made that trade-off, and now I, why I want that versus another kind of thing.
Yeah, one of the things I want to hit on there is going back to the quote-unquote bad taste thing. Steve Jobs was probably one of the persons that got quoted the most about this and his opinions on Microsoft. Now, this is design and maybe other things there where he would just say that they have a lack of taste. They are focusing or optimizing for other things inside that organization. And I would argue that there you can fall off the cliff the other direction. iOS 26 or whatever it is now, so there's ways that even within design there. And I agree that I like that he did focus on the idea of understanding that engineering takes more things than, say, pure software. There's these concepts of resiliency. It's something that you can see and measure, in a sense. The speed of it is this thing, is it portable, which is an interesting concept of being able to move around. I had a very long conversation with Michael Kennedy, be coming out next week, where we talked about this idea of being able to like move your infrastructure around. And that is critical to somebody like himself. And that might look different in design of that to somebody else. Do you feel like, going back to just like a pure Python code type of thing, because this wasn't necessarily what this was about, but having the idea of like code formatting, again, like the tool Black that we've mentioned off and on, that can go through and format your code in a very specific way, and the team can agree on a set of standards there. Does that help some? I mean, that again is just sort of a readability thing. It doesn't necessarily change the quote unquote design of the software.
Well, it affects a couple things, and some of it's subtle, right? So yes, there's a readability aspect. One of the challenges is some of those things are done by like your editor. And so like if you, the old tabs versus spaces argument, what would often happen is my editor would read your code in, convert all the tabs into spaces. And then when I went to commit, it looked like I'd changed every line in the file because every line had a tab on it. And so I had made a code change that only changed one line, but the commit actually changes every single line, which mucks with the delta, right? So having your developers be consistent about these things, one, keeps us all, it makes it easier to read because we're all used to it, but it also has some subtle effects there as well that you don't want to accidentally change things that aren't actually being changed. And so the other aspect of that, I find developers tend to be very heavily opinionated about it. And so setting down, these are our rules, stops the little spin of, oh, I don't like what yours look like, so I changed it to what I think it should look like. And then the next time you edited it, you changed it back. And all that's just a waste of time, right?
Yeah.
And I think one of the wonders of Black is everybody hates it, but we agree we're going to hate it together. There's something in it that everyone kind of looks at and goes, well, I wouldn't do it that way. But then we're not arguing about the thing you hate versus the thing I hate. We can all just
these are all different parts of the tree.
Yeah.
Yeah. I love these discussions. I think it's always interesting to kind of dig in a little bit into it. The Hackers News thing was actually one of the better, less flamey sections. I felt like it was actually kind of looking at collaborativeness in some ways and bringing other team members in. And so there's some good stuff into there. Well, I think that takes us into projects. My project, I don't know if we've actually discussed Sphinx on the show more than in just a passing reference. And I believe it's a tool that you like to use for documentation. In fact, I'll be including your course. Your course is about documenting a project along with Read the Docs, and I'll use it as this week's video course spotlight. This is the one that you primarily use for doing documentation for your stuff, right?
Yeah, all of them, the libraries that I support, the documentation's written using RST and Sphinx. Yeah.
Okay. So the project that I have this week is a website for previewing how your Sphinx formatted text will look in sort of real time in another window pane. It's at snippets.documat, DOCUMATT.com. Documat is actually a service. I'll talk a little bit more about it in a second. But as you just said, Sphinx uses a very specific syntax. It's called RST markup, or restructured text. I'll have it links in it so you can learn a little more. It's sort of a cousin of Markdown. In fact, there's a path to make them to work together, and this tool actually can support that a little bit. There's a tool called Mist that's capitalized interestingly, just like restructured text is. And you can research that if you want to learn a little more. But Sphinx itself can output in a wide variety of formats, which is nice as a tool, including HTML, EPUB. You can make manual pages and a lot more. And so it's kind of a nice one. With this RST text, the second window pane then can provide a preview as text, HTML. It can also show status information or warnings. There's a nice example document that shows off much of the syntax in a well-formatted example, creating sections, inline elements, lists, code formatting, all the types of things you might approach inside there, even graphics and stuff like that. And in your course, you argued that Sphinx is the de facto standard for Python projects. And I know that its tie into Read the Docs makes it really popular for hosting documentation. And I definitely see a large amount of things in Read the Docs as far as in the Python world. Do you still feel that way? That it's like sort of the de facto?
It still seems to be the one that I see most. Yeah.
Yeah. Okay. So again, there's a link on the page directly to Documat. And this is a tool that's a little bit more like an editor/writing environment for creating your documentation. It looks a little bit like an IDE, but again, a little bit more like a writing tool with publication features built into it. Their tagline is create beautiful documentation, manual, help, or books effortlessly. Something to check out. The site is try Sphinx Docs instantly in your browser at snippets.documat.com. What's your project this week?
So I've got something called tdom. It's by a collection of folks who worked on the T-string implementation in Python 3.14.
Nice.
And one of the project's maintainers is Dave Peck, and he wrote a quick article giving a rundown on how you can use the code, and that's what we're going to actually link to. We've covered T-strings several times before, but if you don't listen to every episode, I'll give you a quick recap. Python 3.14 introduced template strings. They look like F strings, but have a T prefix instead. A T-string returns an object which contains information about the parsed content of the string instead of just rendering output like an F string does. So the tdom library is an HTML toolkit, and it's sort of the canonical example of what T-strings can be useful for. So populating HTML with user input can be problematic, as HTML has special characters which need escaping. So if the user uses one of them and it doesn't get escaped, well, your page won't render properly. And in extreme cases, they can even inject JavaScript, which causes code to run on your page, which generally speaking, you don't want. So you use tdom to build HTML node objects. So for example, you can use the HTML constructor in the library to handle a set of div tags. So instead of passing them in as a normal or an F string, you pass in the content as a T string. And since it's a template, you can include a brace bracketed field to populate the content. So for example, a T string with div, braces, name, close div would turn into a node containing div tags and the evaluation of that name variable, filling in Alice or Bob or whatever you had in it. So if someone puts something naughty in the name variable, tdom takes care of it and escapes it for you. If name contained, say, script tags, the tags would get escaped and stored as less than and greater than character entities instead. So it would present on the page properly and not have the bad stuff in it. tdom supports dynamic attributes like the disabled flag for buttons. It supports lists and dictionaries for things like HTML classes, generators to populate HTML ordered lists, and provides a mechanism to define your own custom components. So if you're looking for an HTML construction library, this would be worth checking out. Or if you want to see T-strings in an actual practical example, then this might be for you as well.
It's funny, Bartosz mentioned that he didn't see the usefulness of T-strings and that it would need libraries from the community and so forth. And it's funny because I felt like we had already kind of started to discuss that this is happening, that people are doing this work behind the scenes. So it's nice to see some more of it kind of coming to the forefront already. I think across this year, we'll see a variety of things using this library to find the usefulness of it.
Yeah, it strikes me as a library maintainer's language feature.
Yeah.
So people are going to bump into it because they're going to have to use T-strings to pass things into those libraries.
Yeah, you don't know how it works because it's a little funky.
Yeah, you don't necessarily need to know how it works under the covers. You just know, I'm supposed to use a T-string here, and that'll be fine.
Yeah. Well, thanks for collecting all these news this week, the mountain of it.
Yeah, and just so that we're clear, PEP 236 is the best on name alone. Back to the Dunder future.
All right. Thanks again for collecting all these articles and news and projects this week. And I'll see you in a couple weeks.
Cheers.
I want to thank Christopher Trudeau for coming back on the show this week. And I want to thank you for listening to the Real Python podcast. Make sure that you click that follow button in your podcast player. And if you see a subscribe button somewhere, remember that the Real Python podcast is free. If you like the show, please leave us a review. You can find show notes with links to all the topics we spoke about inside your podcast player or at realpython.com/podcast. And while you're there, you can leave us a question or a topic idea. I've been your host, Christopher Bailey, and I look forward to talking to you soon.